Well, good evening, everyone. Good evening, everyone. Welcome to today's panel on career on AI and data science. This series is brought to you by Capanova. This organization works to unite, empower, and advance our Chinese American community and broader the community by building community relationships, promoting education and learning, and advocating equal rights and opportunity on all fronts. Today's topic, artificial intelligence and data science, they're transforming different industries and also opening doors to exciting new career opportunities. We're honored to have with us a distinguished group of speakers. They have each bring a wealth of knowledge from their unique perspectives in AI and data science, and they represent a variety of industries and roles. So first, let me introduce our two moderators. I have Michael Ma. He is a junior in McLean High School, a rising baseball star, and has interest in finance. And also Matthew Zhang. He is a Virginia Tech graduate with CS and CMDB major. He's also doing a master program right now in Virginia Tech with machine learning. So without further ado, I'll turn the table to Michael and Matthew. Let them introduce our two speakers here. Michael?
So our guest speakers today are Jefferson Zhou and Kelvin Neal. Mr. Zhou is a quantitative risk analyst at Barrington Fund Management, which is a multi-strategy hedge fund based in New York City. And he's also worked as a fixed income quant at DC Energy, and he holds a master's in data science from Columbia University and a bachelor's in applied mathematics from the College of William and Mary. He was raised in Northern Virginia and attended TJ, or Thomas Jefferson High School for Science and Technology. On the other hand, Mr. Neal is a senior research engineer at the Fundamental AI Research FAIR group at Meta, and he works on neuromotor interfaces. His previous positions include an assistant vice president of machine learning engineering at Sotheby's and a data scientist at Foundry AI. He graduated from Duke University with a Bachelor of Science in Statistical Science and Bachelor's in Computer Science. He was also raised in Nova and attended Langley High School. So our first question to both of you, kind of like just further introduction. What do you do at work? Kind of for Mr. Neal, what is FAIR at Meta?
Yeah, so I guess I can take the first one. The question is, what do I do at work? So I've spent about 4.5 years at Meta, and for the most part, I worked in kind of like recommender systems. So you can imagine like trying to connect people with content they like on Instagram or Facebook. More recently, I've been working on kind of models for neuromotor interfaces. So basically trying to build models that can take signals from your body and try to like determine like kind of movements that your hands are making. Yeah, so that's kind of there's just kind of a research group within Meta, and with kind of like large companies, there's a variety of kind of different organizations, and there's kind of like product organizations, research organizations, infrastructure organizations, and so really kind of a wide variety of different roles that are kind of all related to like quantitative fields.
Yeah. So you said like you work on neuromotor interfaces. You work on maybe the Oculus or the Quest Pro, since I know VR headsets do utilize some of those. Like I know Apple, they really like their eye tracking technology. Like what projects do you work on?
So I probably shouldn't talk too much about any of the projects just in case I say something that I shouldn't say. But I can kind of talk more broadly about like work in recommender systems and stuff like that if you want. Because I've done a lot of my past roles have been in kind of recommender systems, and so I have a decent experience in those, and those are pretty well known.
Yeah. If you would like to, you could talk more about those. I think the audience would be interested in learning more.
Sure. Yeah, I mean, I guess like in general, like recommender systems are like connecting people with content that they want to consume. And so basically we build a lot of like models based on interaction data to try to predict what people might like. And I think, you know, generally like the whole trend of these kind of quantitative careers are, there's a lot of stuff that, you know, people may previously have done like manually or like using rules-based heuristics. And like now more and more these days, we have like a lot of kind of compute power and a lot of kind of knowledge on algorithms. So in a variety of different fields, like we're able to generally like use data to really drive kind of decisions instead of kind of, I think previously a lot of decisions are like implicitly using data. People kind of have these like world experiences and they kind of synthesize it and are able to like make decisions. But really to really synthesize like large scale data, kind of models these days are able to really do that and at like a scale that we previously haven't been able to do before. Yeah, but I guess I've been talking a lot. I'll let Jefferson probably give a brief intro about maybe like how quantitative, like how there are like quantitative applications of these skills in finance.
Yeah, I think just to hop on what you said about the ability to ingest and process large amount of data. I mean, it's really unprecedented compared to before. Like if you just look at old research papers within finance and economics, the type of data that they processed back then, I'm talking 30, 40 years ago, it's a tiny fraction of the amount of data that people use now in actual trading, investment management. So I think, you know, with the advent of this new technology, there's bound to be some very interesting facts about, you know, investor behavior, how markets operate that we just previously haven't discovered before. So sort of conventional wisdom around how to invest actively or passively might change very rapidly.
Going off that, oh, sorry.
No, I was just say like in terms of my day-to-day. So yeah, like Michael mentioned, I'm currently a quantitative risk analyst at Verition, and you know a lot of day-to-day is more active risk management. It's, you know, looking over people's risk-taking, their positions, and you know my specific asset class is equity derivatives. So it tends to be the more math-heavy side of finance. So a little bit of, you know, stochastic calculus, probability, linear algebra, matrix theory, sort of amalgamation of everything. So that's my day-to-day.
Thank you so much. So yeah, kind of going off of that, could you elaborate a little more a bit on what exactly like quantitative risk or quantitative analysis is? I think like quant is kind of this word that we hear thrown around a lot, but a lot of people probably don't know what it is and how has it impacted trading within the financial world and within financial markets in the past few decades?
Yeah, definitely. So, so the original quants of Wall Street, it was really born roughly around the 60s and 70s. So back then, you know, investment banking really dominated the field. It was much more a sell-side driven field. And what I mean by that is sort of, yeah, people tend to be much more discretionary in their risk-taking and their trading. A lot of time people make decisions sort of based on heuristics and what sort of conventional wisdoms passed down. So around that time, you know, it was roughly close to the end of the Cold, well, rather it was in the middle of the Cold War, and a lot of scientists, specifically physicists, they lost a lot of funding from the government. So all of a sudden, you have a bunch of unemployed smart physicists with great math skills and coding skills, which is pretty rare at that time. And then there were certain firms who found like a use for them. Primarily, one of them is Goldman Sachs. So sort of you had this initial wave of migration of physicists to Wall Street, and then those people brought in a lot of techniques that they used to process large amount of data from physics, and they knew how to process it. And a lot of them found that there were some of the math that they used to analyze time series in the hard sciences can be used to apply it to financial markets. So those people brought in these techniques and sort of built the first quant departments within banks at Wall Street specifically. And then the first sort of wave was the focus was much more on pricing complex financial products. So the easiest thing you can think of is probably like an insurance policy. What is the fair value of this? And right now, like obviously a lot of people know how to price it. You have countless actuaries, but back then it was much more an open-ended question. So these people were able to bring in the probability and the stats and stochastic calculus model to come up with a much better price for these complex financial derivatives. And then, jumping forward as compute power grew and we have more and more data, the new wave of quants tend to be much more focused on data science, applying algorithms to make systematic investment decisions. So that's sort of a quick, high-level summary of sort of how quant came to Wall Street and where it's heading to today.
Great. That's really interesting to hear. And both of you guys mentioned a lot about how scalability has impacted both of your fields. And we've seen this massive wave of increase in scale and compute with companies like NVIDIA now topping 3 trillion in market cap. And can you guys kind of shed some light on just what is like the scale of data that you guys really work with within your jobs? Like maybe Jefferson's side, like, and how do you leverage that data at like the speed or the rate that you do to make decisions?
Yeah, I guess I'll go first. So the scale of the data it's really quite large. So we can consume I don't know, terabytes of data. I've never really looked into the actual size of the data, but if you look at the stock market, every trade that happens, every time someone puts in an order or cancels an order on an exchange, all of this data is collected and stored, and it can be analyzed. So I won't go into specifically how we use the data, but I can speak to how a lot of academics might use this data. So this is the biggest possible data set, not possible, but this is one of the biggest data set is within specifically in the equity derivatives world. You have what's called a centralized order book. So you have a set of people willing to buy something and a set of people willing to sell something. And it's a tremendous amount of data because there are several market participants, and a lot of them behave via algorithms, and their decisions happens in the nanometer second. So orders come in and out, and you can take all of this information to get a sense of where people might be heading and what people might be thinking in terms of how a stock is going. So I'm talking more in the high frequency trading realm. So you can ingest all of this vast amount of data. You might have a proprietary model that will tell you, like, with 50.01% probability, the next tick, the next microsecond, the stock will trade up or down by a penny. And you can scale that small edge to a huge number of trades. And really, you only need to be right a fraction of the time. It needs to be over 50%, obviously, but that's enough to make it a profitable business. So, as this is only one example of its application in trading. On the flip side, if you go lower latency, you have hedge funds. Won't speak about mine specifically, but you can look it up on Bloomberg itself. There are hedge funds who use alternative data sources like satellite imagery. There's a very famous hedge fund who will look at satellite images of oil tanks. They will literally look at the shadow that the oil tank casts to get a gauge of how much supply of oil is in the system. And they will go and they will use this data to make trading decisions. And back then, it was relatively unknown strategy, but now it's sort of more commodified and people sort of caught up with that. But that's just to give you a sense of how data is used in my world.
Yeah, that's incredible.
I'll hop on to that as well. Like, yeah, I think basically the scale of data has like grown like tremendously, and a lot of kind of models these days are trained on internet scale data. So really, like, you can't just load this data on your computer anymore and kind of like play around with it. And so another important trend is kind of the importance of like engineering. So you need to be able to like process all this data, and in order to train models on this data like at scale, you have to train pretty large models, and it's also a non-trivial task to get the engineering right to be able to kind of train these large models. You can't just do like a one-line function that will kind of train on this internet scale data. And then when you think about, for example, even when you have the model, if you're trying to apply these models, like if you're using these models to serve recommendations, or like in Jing's case, like make trades, right? Like you need to be able to have these models run very smoothly, and able to like have predictions at scale with low latency as well. So that's a whole another like engineering challenge of like, even after you train the model, how do you really like serve it in a way that is like sufficient for your use case? And like on the tech side, a lot of products, both like mobile apps or like web apps, and a lot of these have kind of machine learning models powering certain aspects of them. And really, like, you can't take forever to like make a recommendation, or if your like models like fail to make a recommendation, it might really like degrade the user experience. So there's also kind of a large engineering portion into like the serving. And then of course, like maintaining, like for example, a lot of these models are like retraining on a lot of data continuously, taking in new data. So there's questions of how do we kind of get the data to flow into these like pipelines to train the models? How do we like make sure that the data is good quality? And then there's also like a lot of subfields where, a lot of companies have a lot of compute, but not all companies have a lot of compute, right? And so you really need to be kind of selective in, for example, like what, maybe you just want to pick a subset of the data to train because you don't want to wait like a month for your model to train. And so there's also kind of questions there in terms of like how do you select a high quality subset, and stuff like that. So really kind of the scale is nice in terms of improving performance, but it also introduces a lot of complexity into kind of these systems, and a lot more to think about than kind of just the like research aspect. Of course, kind of the research ideas are very important as well, but the engineering is also quite important.
Yeah, it's really interesting to hear about. I was at a conference earlier this year in June, and one of the guys who was there, who was a researcher at OpenAI, who was a part of their Sora project. And one thing that really resonated with me there was that he said, kind of with a lot in machine learning, you have to have performance on one axis and then compute or flops on the other. And I'm just kind of wondering, in your experience at Meta working on recommendation systems, like how do you go about that balance? How do you strike the center between those two different dimensions?
Yeah, I mean, I think there's a couple, I think there's like two main kind of drivers of that. One is like product application. So if you're releasing a model that you want to, say, for example, run on device, like maybe like you want to just chat with a chatbot on your device, you're not going to be able to say like train like this, put like a 400 billion parameter model on your device because you don't have enough memory. So you might need a lot smaller model. So one of that, the one use case is kind of like use case driven. The other one is more like practically you only have so many like GPUs. And if you want to train really large models, you're going to have to use more GPUs. And you're going to have to train them longer if you want them to really get like reach their full potential. And so really it's more kind of an allocation of like, if I have this amount of compute, I can either train like one big model, or I can train like multiple smaller models. Maybe I can iterate more on the smaller models. There's typically like processes where like you want to try a different combination of different parameters when you train models to find like the best one. And so a lot of these are driven by kind of resource allocation constraints. You want to smartly allocate your like finite resources to be able to like serve the use case that you want.
Yeah, that's really cool. So you said that basically you have to use limited resources to efficiently train your models. And I was wondering if there was anything else like related to maybe how to actually select a good data set. What are you looking for in that for your models?
Do you want
Yeah, I guess
Oh,
I can take or yeah, I guess I'll go first. So I guess within the specifically the context of finance, let's say you were building an investment strategy. You know, a lot of times the way that people iterate is you don't start off with the most complicated model, because it's sort of like, why would you use a sledgehammer on a nail if you can, you know, because it's like Kelvin said, it's expensive to train these models. It takes time to get it right. Versus, so usually, you know, people start off with a simple linear regression model, and what matters a lot more is, like you alluded to, finding the right data set. So there's sort of, you know, let's say you were working on modeling returns of a specific security, like a specific stock, let's say. So there are obviously well-known factors that drive companies' performance. And sort of after you include all of these factors, there will be sort of unexplained returns that people will try to capture. And what I mean by that is, you will have, you know, whether a specific data set, specific time series that will give you a glimpse into why, you know, a specific stock is behaving the way that it is, that other people on, you know, Wall Street might not be able to obtain access to. One example might be like, let's say you are interested in predicting Chipotle stock prices. So you know what matters is like, well, you know, if the market is down 20% year to date, then most likely Chipotle will also be dragged down by the broader market. But you know, maybe Chipotle is down only 15%. So you might be thinking like, well, why is there a 5% gap? So then you might have, for example, have access to credit card data from people, and you can see that, oh, okay, like this quarter, you peruse all this data, you find that this quarter people spend way more than analysts on Wall Street thought that they would. So you can use this data, you know, to predict the next quarter. Is okay, like so far people have been spending way more Chipotle than, you know, Wall Street might think. In which case, you know, you could certainly hypothetically place a trade where you go short the market and launch Chipotle and capture that 5% spread. So that's a very simple example of how you might build a trading strategy, you know, leveraging alternative data.
Yeah, I mean, data is like very important. Like as Jefferson mentioned, it can be like a competitive edge. If you don't have the right data, you really can't, like you can build complicated models, but if you're modeling noisy data, then really you're just like learning this noise. So yeah, it's definitely important to collect the right data, and also like when you're collecting or when you have a data set, like understanding really like are there like biases that exist in your data that maybe if you model this data set perfectly, it doesn't match entirely kind of your use case, right? Like if you know, I guess if you're collecting like survey data, like maybe you only get data from people who respond, and maybe the responses of people who respond are different than people who did not choose to respond to your like survey. So like if you really build a model and you're able to like really model the people that did respond, yeah, then you probably can predict those people's like preferences pretty well. But you know, if you're trying to extend that to the whole population, then you probably will be kind of mispredicting when you generalize to like your intended use case.
One question I have more directed to Kelvin here is in the last 15 years or so, we've seen within machine learning like a big shift towards deep learning. And for the audience, deep learning is kind of just this paradigm where you leverage these models called artificial neural networks. And these are just models that very loosely simulate the brain. I'd say loosely with the big asterisk. But we've seen a lot of watershed moments during this time with ChatGPT maybe being the biggest recent one that people will be familiar with. But within like recommendation systems and other projects that you've worked on, have you seen how have you seen this kind of impact your work and impact the field as a whole?
Yeah, I mean, I think like as you mentioned, like deep neural networks have been like pretty popular these days and really permeating like a lot of application areas, like also recommender systems, you know, like computer vision, language modeling, as you mentioned. And really, I think, you know, we're able to train these like at scale, and we have a lot of like data that we can really feed these models, and that's kind of why people have really been gravitating towards those. In a lot of cases, like I think people found that, you know, just like blindly scaling up the data really like improves performance, and I think that's why people rush to kind of train these large models on like internet scrape data, because really like scale was a big driver of performance, and more so than like architectural improvements and stuff like that for a while. So I think that's why people were kind of attracted to that. But I think people are slowly taking a step back and trying to see if you know, you can train smaller models like more efficiently. You know, if you can curate the data to like use high quality data instead of just blindly throwing like all the data, and being able to really like train good models efficiently and with like smaller models. Because really like at the rate that these like large models are increasing in both size and the amount of data that they consume, like I mean, there'll be a point where you run out of data, and or like it's going to take forever to really like train the model in terms of like both time, but also like electricity costs. So I think people are definitely trying to really like rethink how we can kind of change some of the paradigms that are popular today to really be kind of that next shift in something that's like more efficient. Yeah.
And switching gears here for a little bit, just a question for both of you guys, since a lot of our audience is pretty young. What was some piece of advice that you would give to your younger self, knowing where you are now and the experience that you've had? Like, just what are some things that you would want to tell yourself that may help you to get to an even better place where you are today?
I think you know, when you're younger, it's you don't have perspective. First of all, you know, when you're a kid, sort of your day is laid out to you. You wake up, you go to school, you study for the next test, you try to do well on your SATs and you try to go to college, right? So I think a lot of time we become very tunnel vision, and sort of in the presence, we let things that will seem small in the future affect us a lot. So for example, let's say you didn't get that A on the test that you wanted to get an A on, or you did worse on the test than you thought you would. In the moment, that sort of that impact is really magnified. But in the future, a year or two when you're off in college, I promise you the last thing you're going to think about is that test that you failed 3 years ago. But that's not to say that you shouldn't study and try to do your best in school. My point is, what defines you is more how you bounce back from adversity and how you keep pressing forward. I think that's something I would like to tell my younger self, is to sort of keep in a more open mind. And the fact that a lot of people tell you to don't fear failure. You should still do your very best to avoid failure if you can. But the point is that I'm trying to make here is, failure and disappointment is sort of part of life, and you just have to accept that. And it's really how fast you can move past it that defines who you are.
Yeah, I mean, I think a lot of that like resonates with me as well. Like, I mean, I think yeah, during like high school and college, there's like really kind of a pretty set path that like your day is like very structured. Like, oh, I want to get good grades and stuff like that. And really, I guess probably not over optimizing for grades is like kind of like a good thing to do, because like getting good grades will like probably help you learn a lot, and so like it's definitely good to kind of try to strive to do that, but like really kind of over optimizing and trying to get that last like A in like all your classes or something is probably not worth the extra effort. And really like kind of the education is really more of a proxy of trying to gain skills that will be useful in both like your career and in real life. And so like like metrics are not always like proxy metrics are not always like perfect, so like you shouldn't really over optimize. They're like related, but yeah, again, like not over optimizing for that. And also I think at least in the tech field, it's really nice to be able to have a lot of curiosity and like build things. So when you're kind of doing projects for school, like your teacher or your professor gives you like a certain pretty like narrow like project to like implement this, like computer system or like this model. But really there's kind of a lot of things that come up when you try to do that in real life. And so a lot of people say like, oh, you should do like side projects and stuff. But really like you should kind of try to find like areas that you're curious about. Like you should be doing like things and kind of tinkering that are really more like curiosity motivated than kind of just like, oh, I want to have this side project for my resume. And if you end up doing that, I think like you'll probably be like more motivated to really go through the side project, and you'll be less constrained in terms of like, oh, this is what the project has to look like. I have to like implement these features, and be more like curiosity driven, like, oh, I want to create this like application that can, make music recommendations for myself. And then really because you're like intrinsically motivated to do so, you'll be able to like really just implement like the important parts and really get it working. And that's kind of, I think a lot of those skills would be transferable to when you're kind of tinkering in real life and in jobs, because like really, yeah, it's a lot of kind of building and like trial and error, and like, sometimes you do well, sometimes you like fail, and really kind of gaining through experience through just like doing things. And it doesn't have to be like perfect. Yeah, so that's my perspective.
That was some really insightful advice. And just to summarize, you guys both talked about how it was important to just keep an open mind and to be curiosity driven over, I guess, grade driven. And my question for you would be like, what activities would you suggest doing, or what have you done in your past that might have led to like your current job or like just current interests?
I guess for me, I read a lot about the field. I think, you know, the sort of like the whole purpose of, today's meeting is to break down barriers, right? And back then, it was very hard to speak to someone in this field. At least people in my field are sort of notoriously tight-lipped, and usually for a good reason. So that's why I had to rely more on books, a lot of time on biographies, like nothing technical, just people's thoughts and why they went into the field. I think that sort of shaped my thinking and sort of gave me a reason to want to go into it. And I think in general, like what motivated me was sort of the drive to find something that no one's found before. I knew that I wasn't going to cut in the hard sciences, and I took an early interest in financial markets. So I just wanted to find one thing about financial markets that no one's found before. So I think, like we've talked about, all night, is this innate curiosity and this desire to learn something that no one else has learned or thought of, and to come up with novel approaches to problems that we've known within my field, and to ideally share it and educate the community within finance.
Yeah, I mean, and for me, like I was always like pretty interested in math, and so kind of when I like went to college, I did a decent amount of like exploration in terms of like more like math adjacent kind of fields. I took classes in like econ, statistics, like comp sci and math, and really like a lot of kind of my interests just like developed over time when I went into college. I really didn't know like what like long term I was kind of interested in, and I just knew that I really like kind of math, and so probably something related to that. And I think that's also like totally fine to like explore. As I started taking like math and econ classes, I figured out what portions I like, what portions I don't like, and really like meeting people with like similar interests, and then kind of getting more perspectives from them as well, to really understand more like what's available out there in terms of like the wide spectrum of like careers people can have. So yeah, really kind of did that. I really liked statistics, and then because like computing is a big part of like statistics or like math these days, or like applied math at least. I picked up like comp sci as well. So really like a lot of times you kind of just have to, I don't know, that just follow some of your interests, and then you kind of like learn more about those fields, and then really like reflecting on like what portions of things do you like, what portions of things do you not like, and kind of like moving closer towards the things that you do like. And a lot of times like your perspective might change. You might think like, oh, I really want to do this thing, but then you take some classes or you have an internship in that area, and then you realize like, oh, this is like actually very different than what I thought it would be. Or maybe it is not different, but like you realize like, oh, I don't know if I could like do this for like a long time. So yeah, really just also like reflecting periodically.
Yeah, I feel like I can definitely relate to that. So a lot of time, like we go into a career, we have like a goal. It's like, I gotta get into this company, I gotta get this job. But I feel like a lot of time, maybe you get it and it just turns out to not be what you think it is. And it's not a reflection of the company or yourself. It's just that as you go through life, your goals and your priorities will change, and that's okay. And it's fine to have that evolve over time. And I think yeah, I think in general, it's just good to try to find something you're interested in and to keep at it. I'll give you an example. Like personally, I remember back in high school and college, I hated coding, man. Like I couldn't code for my life. And but I found out that I was interested in math. I like working with data. And at some point, it's like you can only spend so many hours working on Excel before you're like, okay, there's got to be a better way. And then it's like maybe it's time for me to finally open up like Python or something and actually figure out how to use this thing. And then a lot of times like I view sort of math, finance more as math and like comps more as tools to help you solve a specific problem. And a lot of time, I think people's goal should be to find that one problem that really drives you. And then a lot of things will just fall into place. And you'll sort of develop like an innate desire to learn the tools you need to solve whatever problem you're interested in.
I think those are all. Oh, go ahead.
I was just gonna add a quick point. Like when I first went to college, I was like, oh, I'll become an investment banker. I'm definitely not an investment banker.
You're gonna scare Michael away, man.
Yeah, that actually kind of perfectly dovetails into what I wanted to ask next, which is for people on this call who are in high school, who are probably interested in AI and data science and maybe want to learn a little bit more. I know for certain that when I was in high school that I didn't really have a good grasp at all on what this field was. I couldn't really tell you much about it. But I just want to hear from you guys. How would you recommend someone like trying to break into this? What would you recommend are like the first steps to start learning, to start getting some more experience and dipping their toe in the water?
Yeah, I mean, I think like one of the really helpful first steps is to have like solid fundamentals in like math and like computer science. Like the field is changing very quickly. So it's not you can't necessarily like it's hard to like keep up to date like all the time, right? But if you have solid like fundamentals in math and computer science, like a lot of these things you can pick up relatively quickly. In terms of like you'll be able to learn much more quickly than if you have to kind of start from even like the fundamentals. So like really having like a strong fundamentals will be applicable to like many different areas that you may be interested in the future. And you'll probably find that if you have these strong fundamentals, once you find areas that you want to dive into, they might not be as hard to dive into as you may think. But of course, you have to still like work pretty hard to learn things. But it's kind of a good first step.
Yeah, I think nothing too much after that. Like a good grasp of the basic math. If you want specific courses, I mean, like the very basic like linear algebra, to have a pretty solid grasp of calculus and probability, just as a starter. And then obviously like nowadays, basically like to become a quant, specifically, you need to be a pretty good programmer, at the very least, like Python or R, and that's just a base. And then a lot of stuff that you will just pick up on the job too. But like Kelvin said, having that good base will help you learn a lot more quickly. And I think I don't know if you noticed this in your field, but I feel like in my field, like people have just become more and more like impatient and result driven. So sort of there's not as much time for people to learn. A lot of time, you might hire someone, you might join a new firm, and you might get a week or two of training, and then the expectation is you need to start contributing, to the team and to the firm. And I don't know, maybe it's a reflection of our society, but I thought that was an interesting trend that I noticed. I've had 4 jobs, and sort of in each job, I've had less and less ramping time, training time, and a lot of time, like literally by day 2, day 3, start pushing for the production, start moving contribution, and start coming up with analysis. Like, do you think that something that you observe too, like over time? Maybe it's a consequence of AI and advancement technology.
I mean, I think like over the past couple of years, you have like observed something similar, but I think it could be tied with just like, you know, the economy cycles, right? Like when the job market's more competitive and, you know, like interest rates are higher, people are going to lay off more people, and really like there's going to be less kind of roles that you know, a lot of like larger companies, when they have like a lot of like funds, they're able to like really invest in like people and kind of like get people to learn new skills and like not necessarily need those people to be productive, like, you know, very soon after they're hired. And as, you know, the money gets tighter, like, you know, it's swinging more and more towards people like we just need people to really do this and be able to like have enough experience doing this, and kind of less on like, oh, we're willing to like invest in these people. I guess also a tangent that I will go on is like, I feel like you know, we've been talking a lot about kind of some more heavy like quantitative roles, but really there's kind of a big spectrum in how quantitative roles really are like in industry. And I mean, I can just talk about like tech and tech adjacent industries because we have like a lot of tools now. Like you don't have to go as deep if you don't want to in a lot of these like quantitative fields. Like you know, there are like on one end you have people who are just kind of using these tools and more kind of on the business side, like really like, okay, we're going to drive these business decisions, but we're going to leverage data to do so. And you know, you might be, if you can kind of like pull data, visualize trends, that might be enough to really like do your day to day and you know, like make good business decisions. And then you have like kind of people more on like the other end of the spectrum, where people kind of like researching like new algorithms and kind of scaling and stuff like that, and some like more exploratory stuff as well. So really like, there's kind of like a wide range of spectrum in terms of like what quantitative careers look like. It could be more on the product side, more on the business side, or more on like kind of the research side. And really the good thing is this kind of flexibility to based on your interests, like really pick the end of the spectrum that you might be interested in. You know, like using quantitative techniques in fields are like, it's very popular these days, and it's probably going to improve like businesses and stuff like that. But you can also, yeah, again, pick what end of the spectrum you like, because some people might like the math, like really going deep into math, but some people really want to see like the high level product fit together. So another thing to think about.
Yeah, I think that last point is incredibly important. And like you were mentioning earlier, this is kind of like an ever-evolving field, and it's moving at a really fast pace. And touching on that, where do you guys see this field going in the future, in the next 5, 10, 20 years? And also, where do you see are like areas for untapped opportunity within AI or data science that people on our audience might be interested in as they progress further into their careers?
I feel like if I knew, then I'll be billionaires by now, right, Kelvin? Like if I knew exactly which field to invest in and to develop. But yeah, I guess on a serious note is, I think, you know, at least for me personally, what I found really interesting is the intersection of, you know, AI and data science with other fields that might be that we don't think is very related. I'll give you an example. Is I think biotechnology and AI, like that intersection to me is extremely interesting. How people are able to quickly iterate on drug development to solve novel diseases. I think you know, like the basic economics of it a lot of time is, if you have a very rare disease, then it might not make sense for drug manufacturers to invest hundreds of millions and billions of dollars to cure it. and to sell that drug if only 1,000 people in the world have this terrible disease. But with the application of this technology and the ability for drug manufacturers to quickly iterate and to come up with prototypes and approved drugs to, in general, alleviate suffering of these people, I think it's something that that few have thought of and have dreamt of. I think that's sort of curing and solving these novel diseases is a field that I find very interesting and exciting. But not to be too pessimistic, but there's always the flip side of it, which is because of how easy it is for these technologies to use, you can see how there can be bad actors that are able to really weaponize this technology and to cause harm to society. So I think as much as we talked today about these sort of new technology, how much we should learn about them, how much we should use them, there should be an equal focus on making sure that the moral compass of the new generation is pointed towards the right direction. That is not so much about helping yourself, enriching yourself, but to really think more about broader society consequences of your decisions.
Yeah, I don't know if I should follow that, but yeah, I think what Jefferson said is it's like really true. There's a lot of opportunity for kind of applying these techniques to maybe like areas that are more like further behind or like slower to adapt to these techniques. Like, for example, like I worked a lot in the art industry, and definitely there's a lot of low-hanging fruit to apply techniques that are pretty known to work well in other domains to that industry. And so, there's a lot of kind of low-hanging fruit there with like people who are kind of like more on the quantitative side, collaborating with existing like industry specialists and really kind of leveraging the industry knowledge, but also kind of the power of like quantitative methods to really kind of apply these to these areas where we have a high confidence that they should work. Yeah, in terms of like the research side in the future, it's super hard to project like 10 or 20 years. But yeah, hopefully these models just get more and more better, and we're able to do like more things with them. I think we're already seeing that things like ChatGPT, you're able to really kind of increase your productivity, and a lot of people are using it. And I would encourage people to like try to use it in their daily lives. I use like language models in my daily life when I code and stuff like that, and you can really find them to like really accelerate your productivity. And these tools are like available to a lot of people. So really like being able to incorporate these into your day-to-day, just trying them out, you can probably find some ways to like improve your productivity, but also get a better kind of like view of how these models like operate, what are the gaps and like opportunities for improving them. Yeah, and things like that.
Yeah, I think ChatGPT, large language models as a whole, really came on the map in the last few years, and will definitely have a direct influence on future generations and how they are and how they operate in the workplace and in school. And kind of going off of that, how do you guys foresee, because you hear a lot of buzzwords in the news or from different people about how like, oh, AI is going to take over jobs, whatever, but how do you foresee like the applications of not only just language models, but also other generative models as a whole impacting the workplace and future careers?
Yeah, I mean, I think like it's really, again, really hard to predict. Probably, like it'll change the like nature of a lot of like careers. Whether that be like, people are kind of incorporating these in their daily lives, or like it's taking jobs, like it's kind of hard to tell, but definitely feel like things will probably change.
Yeah, I think well, the unfortunate truth is sort of like, just like how, for example, coal used to be such a popular power source, in this country. Transition to other forms of energy left a lot of people behind, and we'll likely probably see some version of that. I want to speak carefully here. We'll probably see some version of that as jobs are more repetitive, gets automated away, and I think a lot of it is sort of up to more, like policy decisions maker to sort of chaperone this transition correctly and sort of more equally, and that I'll leave that up to sort of other people's interpretation. But the idea is to be mindful of these issues and not to completely sweep them under the rug. I think it's, obviously some of these headlines are overhyped and they're sort of more scaremongering, but that doesn't mean that we shouldn't think about these issues deeply and to care about those who might be adversely affected by it, which is why I think that there should be a much greater focus on how to use these technology more ethically, and to again make sure that people are more mindful about these impacts.
Yeah, absolutely. So yeah, just want to go to the chat real quick, see if anyone has any questions that they'd like to ask. We've taken up around the past hour here, so if anyone has any questions, feel free to speak up.
Let me just add, most of the audiences are muted, so we're inviting audience to post questions in the chat box if you have. And meanwhile, you guys can continue any conversations that might interest you. And I actually want to ask a quick question to the two speakers. When you're in high school or in college, do you have interest in this field already, or how do you find this industry? Like how do you get into the industry that you're in?
I think I'm probably more of an oddball here because I did find this somewhat early. Earlier on in college, I knew that I wanted to sort of go into quantitative finance, and I've never really veered off that path. And I do feel like that's sort of more the exception rather than the rule. But I would say like, yeah, like just in general, a lot of time you just have to go and try a bunch of different things to figure out like what you don't like, and then that will eventually, by process of elimination, you'll find a couple of fields that you find either enjoyable or tolerable, and then I would just encourage people in general to pursue what they're in.
Yeah, I guess I mentioned earlier that I didn't really potentially like know exactly what I wanted to do like going to college, but I had general interest in kind of math, and so really just explore that and learn more and more about kind of future paths. And I guess, yeah, I think a lot of times also like the environment is also changing, and so like for example, when we were in high school, it wasn't as big of a kind of interest in all these kind of like deep learning approaches. I think when I went to college, there may have not even been a deep learning class. Maybe, I don't know, maybe one. But really, it's just to say that the environment is also like changing as well. And so it's good to have kind of like a plan in mind. It's also probably, I'd say, good to be like flexible as well. Like, go in with a plan, but really like, keep your options open, and really like, things are changing as well. And just kind of like finding the thing that fits you the most. And even if it's kind of like a new thing that's coming up, like, there's also benefits to like getting into the industry early, right? Like you have kind of more opportunity for growth if you go early, but again, also might like collapse. But again, just try to, there's a lot of kind of luck involved as well. So really what you can kind of control is just going towards an area that you're interested in and really like trying to make the best decision at the time. yeah, with like what you can control.
And we did just get a question. So what does a day in your job look like? And what do you like most about it?
I'll tackle more the second part. So what I like the most about my job is, I get to keep I get to work with a lot of very interesting people and people from sort of all kinds of different disciplines. There are people who are more hardcore machine learning researcher and more like senior research type. There are also people who are more in the softer sciences, like they're more like sales type or like project management type. And I think it's sort of the exposure to this broad spectrum of people that's interesting to me. I get to talk with a lot of different personalities. And I think also within quantitative finance specifically, it's very interesting to see sort of how markets react to news and how it ingests news in general, and not just economic news. Sometimes it might be like geopolitical news. It might be, you might find that like, I don't know, like there's bad weather in a specific part of the world, ruin crops, and then cause like a specific commodity futures to triple in prices, and then suddenly sort of like how do you react as how do you react as a trader, as a portfolio manager, and on the risk side, or like how do you do to control that risk? So sort of all of these things are interlinked and connected, and I think that's really interesting, and being able to develop some foresight and to develop action plans and how to react to any sort of possible scenarios is something that I find very, very exciting and challenging too.
Yeah. I'll say, sorry, go ahead.
Yeah, I was just wondering for Mr. Joe, if there's like anything in particular you would look for in strategies for maybe a client if you deal with that for like their portfolio and interests.
So I won't speak about the current job, but in my previous job, when I worked as a fixed income quant, there were investors who, well, they have certain preferences and inclinations, and also, for regulatory reasons, there were specific names that we couldn't hold in our portfolios. And what I mean by inclination is some people prefer a specific risk-reward profile, and part of my job was to sort of build this portfolio that matches their risk-reward profile, and obviously try to maximize potential returns via different quantitative optimization techniques, and then looking at historical data. So that was part of it, is to sort of work with clients. Yeah, this wasn't a previous role.
Yeah, that's pretty interesting, because I'm like in a competition where we have to kind of build like an investment portfolio for a client. I was just wondering if you had advice. So yeah, thank you.
You probably know more than me. I don't really do single stock picking, so I don't. Do you have any advice?
No stock, no financial advice.
Yeah, this is not financial advice.
So
I know Jefferson talked a little bit about like his job and like what he likes most about it. If Kelvin could also elaborate a little more, that'd be great.
Yeah, sure. So I think similar, like I think really like people are kind of like a really kind of important part of like your job. Like I think for me, like the work is like quite interesting. I think there's a lot of developments going on in kind of like machine learning algorithms and like research, and so it's really cool just to be able to kind of like follow what's going on and really like try out new things that can happen, like new algorithms or like new engineering techniques, and really like being in a role where we're like able to do that. Like we want to get good performance on some of our models, so we're like able to really like kind of try out the latest techniques, and there's a lot of like very smart researchers at Meta, so like learning a lot from them on the research side and engineering side. I think also a really nice benefit is nowadays, as we've been talking about scale, you need a lot of compute to train these models, and GPUs are pretty expensive. So a nice thing is having access to a lot of GPUs to really kind of like train models at scale and gain a lot of experience in doing so. There's a lot of like intuitions you can build when you're training models at scale, and you don't have to worry about kind of as much like the cost of these like model training. Although like on the flip side, I think maybe some startups or like who are more like research constrained, they might have these like incentives to really like develop more smarter ways of like leveraging compute to be like more efficient. And so really like there's also that benefit of that ecosystem where like some of the needs of companies really drive innovation in both kind of the large scale modeling, but also like in terms of like efficient modeling and really being able to get a return on kind of the resources that you spend. I'll also go on another tangent. A lot of times you don't need a complicated model to accomplish what you want. And you also probably don't want to be in a case where like you're trying to solve a problem and you can solve it with this complex model, but the amount of like, for example, on the business perspective, the amount of like money you're saving or you're earning is actually less than how much it costs to train and like maintain your model, right? So like it's not always complicated models are like the solution to things. Like you also have to kind of think about like, is this the right tool to solve the problem I'm trying to solve?
Yeah, that was great. And then there's also another question in the chat. So they asked how one could get a lot of knowledge and expertise on AI in a short amount of time. And I know, Jefferson, you mentioned that you read a lot of books when you're in high school. So maybe if you could give some recommendations, that would be great.
Yeah, no, definitely. I guess like I won't give any recommendations on like textbooks or anything like that, but I think a book that really shaped me into sort of the quant I am today is there's a guy named Emmanuel Derman. He's currently I think he's the director of financial engineering at Columbia University, and he wrote a great memoir called My Life as a Quant. And that book really affected my perspective.
Yeah.
And another question that we got is, have there been any significant setbacks that you have faced in your career? And how did you navigate through those?
You want to go first?
Yeah, I mean, I think like earlier on, Jefferson mentioned that like a very important skill is kind of like being like resilient, and there's going to be probably a lot of setbacks throughout like people's careers, and some of them maybe due to like external factors, like if the job market's just really bad, then there's some stuff outside your control, but also like some disappointments and stuff like that. So like I guess for me, like I guess when I was in high school, I remember I was like trying to get into certain colleges, and I didn't get into like the college that I wanted to. And then I remember like when I was applying for my first jobs, I also didn't get like the job that I wanted initially. But really kind of like an important skill I learned from those is really just like, navigating that and kind of, not really like giving up after like these setbacks, like really just continuing to try to like work hard and kind of like, like learn and kind of like make do with what you have. And really like, there's so many opportunities. Like, if you have one setback, it's really not the end of the world. There's a lot of paths that can like lead to like success. And also there's also a lot of like unexpected paths. Sometimes something's a setback, that you think is a setback is actually not a setback, and it kind of leads you down an interesting rough road. And yeah, so I think like career-wise, like I really just kind of, after I didn't get the jobs I didn't like, I wanted, I kind of learned more about like engineering and stuff like that, and that really like led me to kind of some of these like machine learning like research roles, like kind of following the path of like these days you need a lot of engineering, as I mentioned earlier, to really train these models at scale, and so really like finding some opportunities that might not be like the opportunities you want initially, but that are like good opportunities with like mentors that are giving like the skills that you want, and eventually you can kind of find new paths or get to like even better stuff.
Yeah, that's great. So wondering if you had any advice kind of getting opportunities or just reaching out to maybe industry professionals. What in your experience have you done?
Yeah, I think it's really just a numbers game. Like, and I think just in general, people are not very responsive. So you might get like 5% response rate, which means, for every 20 response you send out, cold call or emails, you might get one response. But you also have to keep in mind that you only need like one or two good connections to land something potentially an internship or like or an externship or a shadowing opportunity. And that's sort of same logic can be applied to jobs. Like, your first job isn't necessarily your last. You don't have to stay at one place for your entire career. So it's like, it is discouraging, by the way, when you shoot out like 200 applications and you only get like 10 replies, and then out of those, how many get converted to interviews. So it's the odds aren't great, which is why like we keep emphasizing to folks to have thick skin and to be resilient. And a lot of time, you might not get that dream job or that dream company, but it's okay, because sort of every step and every opportunity that you do take is sort of a stepping stone that hopefully gets you to where you ultimately want to be.
And I'll add on the flip side of that, like just because you get your dream like college or your dream like first job doesn't mean like everything will naturally be like successful after that. And so like I feel like once if you do achieve like what you wanted to like initially, like it's also important to like continue that momentum and not like really feel like, oh, like now I'm set, right? Because it's also like a long game, and like, just because you're successful early doesn't mean it will guarantee to like last.
It's really a point.
One thing I want to ask before we get to some of the questions in the chat was just, where do you all see the future for your careers? You all have talked a lot about what you guys do now and what you've done in the past, and it's been incredibly interesting to hear about. But where would you like to see yourself going forward?
I think for me personally, I don't know, first of all, and I don't have like a concrete plan. Like I want to become like the head of a department or become like CEO of a company. But I do know that the type of situation I want to find myself in is very similar to what I have now, in a very collaborative environment where, I can give back to my community by mentoring younger people, and also keep learning from people with more experience than me, or from where people with different experience than me. So I think that tends to be the most fulfilling combination on my end.
Yeah, I think on my side, similarly, like I'm a bit more like curiosity driven these days. So like right now, I'm kind of learning a lot in kind of this new area and being able to work at problems at scale. And so, continuing to find myself in places like that. I think like an important thing as I was kind of changing jobs is really like, always like once in a while, like reflecting and thinking about like, okay, what are my career goals, like life goals, financial goals at this point, and like kind of thinking like if your current career job is like fulfilling those, or if like there are better opportunities out there. So like for example, for me, when I left my 2 previous jobs, they were both at a point where I felt like my kind of technical skills and learnings were like plateauing, or kind of the organization also changed. And so also recognizing that and like stopping to like think periodically and seeing like if your career is following the path that you want to follow, can help you make like some more like near to like midterm decisions about those career paths, because yeah, you also don't want to like wait too long to like have realizations. Yeah.
Yeah, I really resonate with like just being proactive, not waiting. I think that's also really important in like the sports world. And another question was, how important is networking to advance your career? And do you have any tips for effective networking?
So I think, you know, like networking is the differentiating factor once you've cleared certain thresholds. So, you know, once you're able to, you know, pass like the basic technical interviews, the behavioral interviews, I'd rather view it as sort of like a boost that will get you more exposures. And in terms of effective networking, I think in general, you know, just be personable and be mindful of other people's time. You know, a lot of time you reach out to more senior people, with people with 20, 30 years of experience. And just keep in mind that those people are really busy with their lives, and to go into those networking sessions where coffee chats with a clear idea of what you want to get out of it, and a clear set of questions you want to ask, and it's really on you to drive those conversations and not on the other person.
Yeah, I mean, I don't think any of that. Yeah, definitely like you want to first build the skills necessary, like the technical skills necessary, especially in this area, to be a good fit for the roles you want, and then kind of interviewing or in networking on top of that is definitely going to be a good combination, because you know, like if you don't meet certain technical skills, like a lot of times you network, people will refer you, and then you don't pass the interviews, for example, and then really like there's kind of a mismatch there. But like if you really first focusing on like building up the core competencies, and then like networking with people, you know, you can find opportunities, and it's kind of more of a way to like find opportunities. You still have to be a good fit for opportunities, but it's a good way to really see what's out there. And in terms of tips for like networking, a lot of times like if you go to places or like find people more like organically, in terms of like, you know, you meet at the conference, for example, or you know, like some like interest group or something like that, you know, you're more likely to be able to you know, connect more in terms of like being on the same page. Whereas like, you know, if you randomly message people on LinkedIn, it might not be as that much of a connection. And also, yeah, as Jefferson mentioned, really like being mindful of people's time and coming in with an idea of like specific questions or what you want to get out of people's time. A lot of times people are happy to help, but again, like people are very busy, and if they have to be like, oh, like, so what do you want to know, and stuff like that, then it doesn't, it's not a good experience in terms of their use of time. So really like understanding what you want, and yeah, just trying to find people more organically.
And we have another question here asking, in your experience, what are key differences between thriving in a large organization versus a small one?
I guess I can speak about the small one. I've always worked on smaller firms. So I think like at the smaller firms, you're really expected to wear many different hats. and to really take ownership. And a lot of time, you know, your bosses might not care why something wasn't done on time. It might 100% not be your fault, but you know, you still have to take ownership of it, which means, you know, if there's a problem that's not technically your job to fix it, you still have to go and fix it to get whatever project and deliverable you want done. So I think there's a lot more accountability in that sense in small organization. But you know, on the flip side, it means that there's not that much red tape to get things done and to get recognition for your work, just because there's too much work to go around, and no one will be fighting you on recognition. It will just be like, you solve a great problem, you solve one problem, great, congratulations, now move on to the next one. So there's a lot of sort of that kind of mentality, like just get things done and keep it moving.
Yeah, I think I'll add on to that because I worked at both the startup and kind of larger companies. Yeah, I feel, at least in my experiences, like startups, you kind of do have to like wear more hats and like really like also think about heavily more on kind of the practical side of things. So like you want to, you know, accomplish a task, like, you know, create a model or something like that. And you want, it might not be like super clean, but you might want to just like first put an initial iteration out there and then kind of like iterate and get like feedback there. There's a lot of kind of practical considerations because, for example, like, you know, maybe I am like a really good engineer and like I architect this like crazy system and it takes me a year, and then by a year, like the startup ran out of money. So like really it's a lot driven by like practical considerations. But the nice thing is like being able to like a lot of times it'll be a good opportunity to have a close mentorship with people working aside you because it's much smaller team and much more collaborative team. And so there's not as much like, it's really everyone has the same goal. They want the startup to succeed. There's not as much politics in terms of like, you know, everyone is kind of doing the engineering or like the product kind of work to really try to make this product a success. And then on the larger company side, I think one skill in addition to the technical skills, because there's also opportunity to go like pretty deep technically, because, you know, there's just more funds to do so, is really like collaborating with many different teams. And so you might have to collaborate with multiple teams to finish a project. And these teams might have different incentives than you. And so you also have to think about like, it's not just how do I build this, but like also how do I align the incentives of these different teams so that, you know, that everyone's incentivized to have like a good product as an outcome. So yeah, I think there's a lot of kind of non-technical skills as well as technical skills in large companies. Also, I think larger companies, some of the larger companies are more, because they're more developed, they're more focused on career growth as well. So like there's more structure in place for people to really like grow their careers, where maybe startups, you kind of have to advocate more for yourself. Although there's also some large companies where you have to do that as well. But there's also differences in kind of whether or not people are thinking about that.
Great to hear. I just want to make sure that we're good on time here. I know it was around 20 minutes ago that we got the notification about Q&A, but if there are any other questions, please feel free to ask them.
Well, I think we're at the final 3 minutes before we're wrapping things up. First of all, I want to thank you, Jefferson, Calvin, for your sharing your time and your experience. And also thank you, Michael, Matthew, for hosting this session. Actually, I have a very brief question, actually, probably a dumb question. Like, what is the difference? I mean, I hear these buzzwords like deep learning, right? Large language model, generative AI, all these, like, what is the difference between all the buzzwords?
Yeah, I mean, like the ones that you mentioned, like deep learning is kind of a technique, and people can apply it in like different ways. They can apply it to like generate stuff. They can apply it to like language modeling, like creating those chatbots and stuff like that. I think another kind of very hype term right now is like data science and AI. I think those are very like big buzzwords, but really there's a wide range of what those mean for like different roles in industry. I think like, nowadays, depending on the firm you're at, like data science could mean that you're actually doing like some research, or it could mean that you're like creating pie charts on Excel or something like that. Right? Like there's also a wide range in what that means. It seems like nowadays it's just those two terms broadly mean just applying like quantitative techniques in different areas.
What I do see right now, a lot of people are saying that in the past 2-3 years, maybe it's economy driven. It is not very easy for computer science students to find internship or as good job opportunity as they used to. Is that what you see in your industry, as far as does it has relate to the AI trend that we're seeing, like replacing the job opportunities or eliminating? Is that what you guys see?
So I think the market in general has definitely become tighter, with rising interest rates. Firms are less able to make investments, and new people cost a lot of money. So I think unfortunately, like it has been in a little bit of a downturn relative to like the early 2010s, where it feels like everyone with a comp sci degree can just walk in to a career fair and walk out with 5 internships. But I think, but that's not to say that it's not still a great career to be had for people within the comp sci major. I think all it means is really that you need to be open to roles outside of the biggest and the most famous companies, and to really build your skill set, and to also build softer skills that haven't been traditionally emphasized and focused. Things like Michael mentioned, like how to effectively network, how to find your domain. I think those sort of are much more important than perhaps before.
I think this has been a very insightful session. Thank you guys so much for your time. And I'm pretty sure that, as I mentioned earlier, we'd like to invite you guys back maybe next year or in a couple of years, and hear your progress in your career and your overall take on the industry and on the progress of this whole AI and data science trend. Well, thank you. Thank you, gentlemen, for your time, and I hope to see you guys soon.
Yeah.
And thank you, audience, for joining us today, and I hope to see you guys in next month's session. Thank you for your support. Good night, everyone.
Thank you, Mr. Zhou. Thank you, Mr. Neil.
See you.
Thank you.